Hello, hello. Hey, Thiago, how are you doing?
Hey, Armando. I'm doing great, thanks. How about you? How is the Ignite?
I'm doing great. Let me make sure that I have my audio here right. This sounds good. This seems good. Yeah, I'm doing great. I'm here at Microsoft Ignite in San Francisco. So I'm local. I'm in my area. I didn't have to travel anywhere. And I am at the Moscone Center West building where most of the sessions will be. So it's great to be here in our last session together as the schedule, man.
Yeah, we are on track.
Is my audio going through okay? Too much
Yeah,
noise, background?
it's good for me.
All right. And welcome to everybody who's watching live our last session of this second installment of Fabric Talks with my friend Thiago Balabucci from Portugal. I'm here in California, in San Francisco. And we are here for our last session on Microsoft Fabric. Thiago was very focused on security because Thiago is the boss guy in front of
Yeah,
the nightclub there. No, no, security here. And
no problem.
I focus my sessions mostly on performance and understanding the differences in between working on a regular databases and even with Power BI sometimes, and working with Fabric and working with One Lake and how the data is stored in the One Lake and the different approaches. Right, Thiago?
Yeah, that's right. So you got the performance and I got security. It's better together.
So there we go. High five. Hit there, hit there, hit there. There we go.
Yep, there you go.
There we go. So for today, for the next 25 minutes, 30 minutes or so, we'll be talking, both of us here with you guys who are watching online. And I'm trying to keep an eye here on YouTube and LinkedIn. We are streaming to both sides at the same time. I'll try to keep my eye here on the interactions for questions. So if you have any questions as we move along, please shoot them. All right. Tiago's, your sessions, you delivered three sessions already, right? All of them
Right.
on security. The first one was on SPN, is that correct?
SPN, yeah, how to use SPN with copy into command and open row set or data warehouse. So the
That was a
second
very good
one,
one.
yeah, that is a pretty cool because every single week I still getting some customers that are raising these concerns and how they can make sure that the warehouse is secure or how they copy the data in a secure manner. So
How to ingest data into the warehouse using warehouse resources, right? Because there are many
yeah,
ways you can bring data into the warehouse. But that one that you showed to us is using warehouse resources in a very secure way. That was an awesome session.
yeah, that's true. So yeah, then the second one is you delivered a session about index, if I'm not mistaken. The first one that you delivered, what was that?
Yeah, the first one was the second one was about the data format, right? My first
Oh yeah,
one, the
second
second
one.
session, the series, first one of my on my one was the data format, and that how Fabric stores data in one lake, how data is actually stored in one lake in the Delta table, and how that changes things, right? How we should think in a different way, like it's write once, read many, right? And the accumulation of data and all the structure, the dictionary, and all of that, which we'll be seeing again a little bit of today. And your third one was on your second one, the third one in the series, right?
Yeah, the second one was related to not the workspace, one lake security. I was trying
that
to not
that
miss.
very new feature, right? The
Yeah,
one
that's the
link
new
security.
one. Yeah, the one lake security is finally here. So it's great that we have this feature. It's promised a lot of things, and it's one of the amazing things that honestly, this is one of my favorite feature in Fabric so far.
Yeah, nice. My second one, the fourth one in the series, was about indexes because our friends who are connecting and following the series, they may be coming from relational databases, and if you want performance from relational databases, you need indexes. But this is not right. Fabric is not a relational database in its core. It does have SQL in Fabric, which is a relational database, but Fabric in itself, it's an analytical database, right? It operates on a different perspective, a different paradigm. And in that sense, we don't use indexes. There are no indexes in Microsoft Fabric. and actually in Delta tables, right? In Delta format, Parquet, and all of that. So in that session, we went through some of the ideas of the Z order and how it's important to organize the data in a manner that will support the majority of the query predicates, and also the secret sauce inside Fabric that is the V order, right? That we
Yeah.
usually should save for the if you're using the medallion approach, we usually should save for the golden tier, which is to support queries for analytical purpose. We usually don't use that when we are still building the data, organizing the data, normalizing the data in terms of magnitudes. Right, Thiago?
Yeah, yeah, that's correct. So the V order is the, let's say, the secret sauce from Microsoft. So
Yeah.
only,
And last week it was super cool, right? Last week you showed
yeah,
us the workspace, right? The private
exactly.
workspace set.
Yeah, the private, how we can lock our workspace in a secure manner where you can control what is coming to your workspace, the inbound connections, and you can also control what is going out your workspace. So the outbound connections. So these are features where folks are waiting for so long, and now it's finally here as well. So it's pretty cool features for security.
So today we're going to be talking about the design of the table or tables in your model. But I like to, I know I was thinking about when we actually did this review of the series. All these videos are recorded. They are in the playlist in our Lasorda Data Labs channel here in YouTube. And please go ahead, sign up, review the videos with us, and send us your questions and send us your tips. What we would like to see next. We're not gonna have any collaborations in the month of December because it's holidays, so I'll be by myself for most of the month. And January, I want to pick this series again, and I would love to hear from you guys who are following along with us online. What topics you like to see here around Fabric, right? But for today, I have this. Let me add this one here to the stage. Today, I have this,
Mm,
and the topic of the day is, and some, I cannot tell you how popular this topic is. Every customer that I go to, they're like, I have this table with 200 columns. Is that okay to have this table with 200 columns? And the answer, I mean, as a consultant, the answer is always it depends, right? That's what we tell people all the time. It depends, right, Thiago? It always depends on your use case. But there are
yeah,
some very good rules around that one, and specifically when we're talking about Fabric. And one of the things we need to remember, because we have seen it already when we were talking about Fabric, is Fabric stores the data in one lake. And when it stores the data in one lake, we have the logical idea that the data is in a table when you are working with tables, right, with structured data. But in fact, what we have there are files, a collection of files there under the hood, and those files are in Delta table format. So, from that perspective, from the storage place, that's the Delta table, that's fine. But when we start working with the data, depending on what you're doing, the engine that will load the data from the Delta table into memory would like to see the data on a particular shape or organization, right, Thiago?
yes, you're right.
If you're doing, it's not the focus of today's session, but if you're doing, for instance, AI, and you're doing AI model training, right? You're doing your model training inside Fabric, which is also another topic we could go go through some other day. Usually, those model trainings, they like to have one data structure that in PySpark is usually known as the data frame. Generally, inside the AI world, people call that the data set. So you have your training data set, you have your testing data set, and then you start using the data in production, right, which is your production data set. And for those model trainings, they like to have one structure, one data structure. So that would be something that resembles a table. It may be a rag table. It's not like just columns and rows, but a particular column, a particular row and a column can have multiple values in there. So it's different from what we do in relational sites. But the point is, it's one data structure. But that is what happens in BI. I mean, in AI. So the AI and BI, AB, right? AI and BI, easy to mix them up. But that's what happens in AI, right, Thiago? Here we're
Yes.
doing kind of focus on the BI side. And when we do a BI side, see if Thiago's paying attention. What's the engine that deals with data when we do Power BI? Let's see if anybody live here can answer that. Let's see. It's the same one we're doing in Power BI, right, Thiago?
Yeah, it's yes, almost the same one, I would say. If I
Depending.
got the yeah.
Yeah, go ahead.
No, no, yeah, it's I would say it's the same one that I think of is going to be very similar. So the engine that you use in Power BI, I'm not a Power BI expert, but I
Mhm.
know a little bit. So do you have any answers in the chat?
No, people are shy. There's some people following
Okay.
live, but people are shy. They did not reply yet. But I
Yeah.
can hear your thoughts from here, and you are correct, right? We are using what is known as the very pack, right? It's the
Yeah. Very fast.
specialized very pack for Fabric. So there is a very pack that works with Power BI alone when you're doing Power BI Pro, and there is a very pack that works with inside Fabric that deals with one lake. So there is this thing you probably gonna check that out later on your own time if you want to take a look on that one. But when you're working with BI, you're doing your reports in Power BI, your semantic model that serves data to the reports can be on direct query, can be on import. Those two are common to Power BI. And when you're doing Fabric, you can do direct lake, which means the data is in one lake, is the data we have been discussed so far. And what we are seeing here on this diagram on the screen right now is an example of a very simple dimensional model. So regardless if you're doing direct lake or import or even direct query, you will have a model like this. And here is the first important thing to answer the question about, how wide can my table be, before I start getting into trouble when collecting the data. The first thing you have to understand is when you're looking into this and you see, let me see my mouse, where are you? Let's see, I'm mobile today, so
Hmm.
the mouse, I don't have my clicker, but here's the mouse. There we go. I got this guy, and let's get the laser
Amazing.
pointer. There it is. So when you're seeing these tables here, and if you're coming from a relational database, you're like, these are tables and these are relationships. I'm familiar with these things, primary key and foreign key, and this you are familiar with those there, but you're not familiar with those here because there in the relational database, these things are to enforce integrity. Like the row in a fact table must be related to a row that already exists on the dimensional table. In the BI thing, in the BI world, in Fabric, we don't enforce that. That thing is enforced before the data comes into the tables. We want to believe, right? I will cross our fingers that when the data
Yes.
populates these tables, they are consistent, right? There is no orphan rows, right?
Exactly. That's a good point. So where we are going to enforce, not enforce, we're going to make our validations one step before. We're not going to rely on the engine. So you are a developer, or BI stack or data engineer. You
Data
are in
engineer.
control of the let's say impose these constraints and not skip this or not push this to engine.
Exactly. So all your controls, all your validations done before in the bronze or silver, usually in silver, as the data comes into here. When the data gets into here, these relationships, they are not for, let me see, clicking here, here we go, let's see, yeah. So these relationships are not for validations or not restricting data coming in. The idea of these relationships is that they are filters, and that's a very important thing. These
Yes.
relationships we have in between tables, they are filters in between rows on one side of the relationship and rows in the other side of the relationship. So these are not, these are actually like where clauses in a SQL statement if you're coming from the SQL paradigm, right? Index in Power BI or in Microsoft Fabric, this is called the DAX context. You know what is the filter for the DAX context for rows to be retrieved? So down here, for instance, I have sales details. If I click in a sale order, because there is a relationship in between these two and it is a one-to-many, it's not going to check if the rows here are related to rows in here. It actually going to do the other way around. You will get one, the key you assign up from here will filter the rows from down here based on the value on the column and row of this particular table. So relationships, it's a very important thing to keep in mind, right? Relationships are for filtering, and when the user uses this in the report, in the Power BI report, they usually take advantage of this, but they can change this filter context using DAX. But that's another topic. We're not going to go in there, right? They can change the things in there. So
Yeah.
with that in mind, if this is just filters, these same filters we have with relationships in here, they work within a table. So in theory, I could combine all these seven tables here into one table, a wide one with all those columns together in there, and perhaps the IDs I could get rid of the IDs because I could keep, since they are being combined already, right? The final result doesn't need to keep the IDs, but the point is I could have one very wide table, and it would work exactly the same way. The reports could use those columns and do the filters. I could get to the exactly same result. So if this way or one wide table works, how many columns should I have? Wouldn't it be easier to have only one table, a very wide table, right, Thiago? Wouldn't that be
Yeah,
easier?
yeah, it would be easier. But my question for you is why we don't do that? Why not
That's a
having this?
that's an excellent question, and the answer to that question goes. I mean, we're talking mostly we're talking focus on performance in here, right? So the action, the answer to the question goes into performance. We want to know about performance, and as we discussed last week, I mean, on my session 2 weeks ago, not last week, but my session 2 weeks ago, session number 4, uh, you're only going to see performance penalties if you do a bad choice here in terms of multiple tables or one table. If you have a lot of data, if you have like 10 megabytes of data, you're not gonna feel it. But like in my cases, people come to me only when the thing is really like hopeless, and the people come to me and they're like, this thing is sluggish like hell, and you start paying that penalty, get super sluggish when for two reasons, main reasons. We have a lot of data, you're talking about gigabytes of compressed data already in the model. And the second one is when the DEX really sucks. If someone writes a DEX that's really bad, change the filter context in a way that's really bad, even if you have a smaller data set, it can also be very sluggish. And not counting, of course, direct query. So the reason to your question, right? The reason we do one or the other goes into performance, and one of the main reason for performance. I mean, one of the main reasons that affects performance is in my next slide here. There you go. Move. There we are. Is on this slide here, and this is a screenshot from a tool that our friends from Italy, right, Alberto Ferrari, and his his buddy there, they created this tool for us called the DAX Studio. And this tool, it shows us things inside the model. You have access to these things inside Fabric using the semantic model that we discussed before, right? There is a library inside PySpark that is already loaded in Fabric for you, that you can grab this information here. My just in between the two of us, Thiago, my Fabric capacity stopped working because I forgot to renew, and I was trying to get it renewed, and I didn't get. So I went Plan B and got this screenshot here. But the idea here is the same. What we have here is, you see, there are. And this is a particular table here. These are the columns of that table, and then we have these things here about the size of those columns in the tables. Notice how this column here is super large, right? While other columns here they tend to be smaller. Why? Because of cardinality. Every time I have a column that doesn't repeat much, has individual values and unique values, there is no compression, so the column tends to get bigger. As the values repeat, very bad, Fabric in that case can, when creating the files, can compress those information, and it goes pretty much the way they are into very pack already compressed. Then the very pack just creates the indexes in between, I mean, the relationships in between those columns so they can map to each other. As these columns get bigger in size, your model performs worst. It gets worst performance. So one of the main reasons we don't use one very large table is to prevent model bloating. Meaning, if I go back one slide here, I get this, let's say here, this customer table here, and I have a name here for this customer, right? This name. So let's say the name is a column of 200 characters, and we have a very good customer that has bought that has put in 1 million orders, right? And order details, 1 million rows inside my table. I could keep that one very wide table with that name in there, but that name will be repeated 1 million times. It can be up to 200 characters, which is a lot of information. You do the math in there, you're in the gigabytes already just for the name. So that's usually a bad idea with compression, because compression, there are many ways. It's not going to be like one row for that name for all the rows that are in the other columns. The relationship will have to be segmented for batches of information inside the fact table. So the main reason not to have all the columns in only one table is to avoid bloating, right? To avoid this total size here, this to go crazy, and your model to be larger than it needs to be.
Yeah,
Am I still alive?
yeah, I can hear you.
Okay, cool. Does that make sense, Thiago? What do you think?
Yeah, of course. So basically, we are preventing to blow up our resources in a manner to divide or spread the columns across tables.
Exactly. Yeah, exactly that. And because we are avoiding doing this, we are using less memory. And because we are using less memory, the model is lighter. And because the model is lighter, the rendering of the reports will become faster. So, if you want to learn a little bit more about that, I got this QR code here from the SQL BI guys, where we talk about the cost of relationships when you have these columns, and if they repeat too much, if they are segregated too much, how that taxes the performance of the model and the performance of your dance calculations. So if you're following online or live right now, right, or you are watching this recording later, go ahead, scan that one, take a look on their articles. It's an old one from 2015, I think, but they have updated it, and it's a very good read. You're saying, Thiago?
Yeah, I have read that plenty of times. So I always have to go back there and learn stuff.
Cool. So to wrap it up, factors to consider, right? Why you don't want to have one very large table. For the most cases, again, if the data set is small, it's not going to affect performance much. But if the data is larger, And large means how much memory you have inside your fabric capacity, your nodes. Like if you have an F2, not that much data will blow up your F2. If you have an F64, then you can get more data. But again, you're just delaying a problem, right? If you don't model it right. So some considerations in there. First, the semantic model is a columnar database. Having 200 columns doesn't necessarily mean that you're going to have bad performance, because when you get into your report's not going to use more likely the 200 columns. It's going to use like 10, 12 columns. And the fabric, right, the very pack engine will only pick those columns from memory. So it tends to work without much impact. But on the first read, it will populate memory, it will hydrate the memory with the entirety of the data set. So if the data set is too large, it will take longer to populate. But after populating, after warming up, working with a few columns, if you have 200 columns on the table, it's not going to affect performance much. Still, you don't want to do that because of the other factors. The other factors will go along this, right? Watch your cardinality. How do you check your cardinality? When you are importing the data, when you're transforming your data in a medallion structure, you can take a look on those steps, right? Make sure you remove data you don't need, and remove data that cannot be compressed. They're too unique in the columns. Watch out for columns with very long strings. Those don't compress well, right, Thiago? They are really horrible for compression.
Yes.
The engine tries to chop it up and create some shards of those of strings. The best approach for very long strings is always keep them on a side table, right? Never put the strings on fact tables that have metrics, because those fact tables tend to be the largest ones, and there you don't want to have strings, period, right?
Right.
And also watch out for the data type of the columns, right? If you can use simpler data types that can compress better, if you can use integer instead of double or float, if you can use date instead of date and time, if you can separate date and time, all of those approaches, they help with the performance and the compression of the data in the table. Right, buddy?
Yeah, and let me just share really quick things with you, Armando. So the data type is important, and I was working in a customer today where a friend of mine that is a Power BI expert pointed
Nice.
them to the wrong data type.
Oh,
They
look at
had
that.
a string data type in a column that was supposed to be integer, and the relationship was blowing up and out of the memory because of these things. So you brought this pretty well.
Thank you. Thank you. You see, my point exactly. So we are up to time to our friends that are following online. If you want to learn more about this, follow me along here on the channel. Follow Thiago too. Thiago has a very good content online on YouTube as well. And bring topics you like to see next year. I'm trying to
Yeah.
find more people to collaborate with me. It's always good to have a good friend on the other side to talk about and exchange ideas. Like Thiago just added this important real life scenario that he brought to us. Thiago, thank you so much for taking the chance and collaborating with me here in this series. Thank you, my friend.
Yeah. The pleasure is mine. So I'm glad that you brought me here. So thanks so much for the opportunity. And well, you guys, please connect with me on LinkedIn. I'm more than happy to help you out. So thank you, Armando. And that was
My
amazing. Really
my
amazing.
pleasure, my pleasure. Let's do another one next year, right? One or two more.
Perfect. Yeah.
Sounds good. So signing off here from Microsoft Ignite in San Francisco. And if you are here in town, I will be there at the South Building at the Fabric booth, talking about the data factory and SQL databases in Fabric. Come along, let's take some selfies together and talk about Fabric and everything else around Fabric. Have a
That's
good one,
great.
everybody.
Enjoy.